Hello, welcome to the first lesson. In the previous videos, I showed you how you can download the Python through installing the Anaconda Navigator. I also showed you how you can install the Visual Studio Code. When you install the Anaconda Navigator, it comes with the Anaconda prompt and the Anaconda PowerShell. In the previous videos, I told you we are going to be using the Anaconda prompt alongside the Anaconda Navigator. We are going to use the Visual Studio Code to debug. So if you have not been able to download this Python dependencies of Python source, you have to go back and watch the first video on installing Python. I will also encourage you to go back and watch the second video on creating environments. In that video, I cover topics like how to create environment, why do we need to create environment. And then you also need to install the packages, the pandas library, which we are going to use for data management, and also the matplotlib for visualization. We have other libraries we are going to explore, but for the meantime, these are the two libraries we want to use. All right. Before you start your any Python analysis or Python interaction, or you want to code, I will encourage you to load your Anaconda Navigator and see your environment is still fine. And we're going to do that. So if you go ahead and open your Anaconda Navigator, I already have it open. You're going to start with the base environment, and then the environment you created, you are going to appear here. We have the name. In my case, I called my environment Joken from the last video. If I go back to home, I'm going to see the different packages that came with my Anaconda installations, right? I have the different types, and I talked about them. And I also mentioned that we are going to be using the Jupyter Lab. You're welcome to use Jupyter Notebook. They're essentially the same. The difference is the way we organize the files. I love using the Jupyter Lab because it gave me more opportunity to interact with different files and stay organized than Jupyter Notebook. All right, so I can load Jupyter Lab in two ways. I can load Jupyter Lab through the Anaconda Navigator. If I hit the launch button here, it's going to launch the Jupyter Lab for me using my web browser. Okay, let's see. So from my C drive, I can be able to pick different folders, and then I can navigate those folders and walk through and be able to get to the folder I want to work, which is what we call our working directory, right? In this case, this is for those who are not code friendly, but I always love to access my working directory using the Anaconda prompt and not directly from Anaconda Navigator. So I want to be able to load the Jupyter Lab from the Anaconda prompt. All right, so what do? I'll show you one other way you can do that. So I'm going to open up my Anaconda prompt. And as usual, the first thing we want to do is to inspect the environment again. So I'm going to say use the command. Already I showed you how you can use the Conda cheat sheet. The cheat sheet have some helpful guide on command you can use on the prompt. So I just say Conda environment env lists. And this is going to list all the environment I have. It says I have the base and the Joken. So I'm going to just tell it. So I'm going to tell my Anaconda prompt to activate for me the Joken. So I'm going to say Conda activate Joken. One thing you want to pay attention is your spelling. A slight misspell can render your program useless, and then you start getting worried what is going on. So you want to make sure that the space, you're careful with the space, you're careful. If you're not sure, you can go to the Conda cheat sheet, copy the the command, and then you can edit it the way you want. So I say now I say conda activate Joken. I'm going to hit enter. Joken is activated. There's one thing we can do. I want to find the directory I am working. So I go to my computer, and in my computer I've already identified the folder I want to work with. Right? For the purpose of audience, I don't want to show where I locate my files. So this is for my own personal use. So you can create a folder in your desktop and open the folder. As soon as you open it, you will see an arrow here hitting down. So you hit the arrow down and then you highlight it and you do Control C. So this is the path where my script is going to live on. I called the folder the script folder. So in this case, I created a folder for Python training. In the Python training, I have here I'm going to put the modules. I have other material, and then I have the script. In the script, that's where I want to have the data, and the script we are going to be using, I'm going to be writing new scripts. So we'll be using those scripts for training. So I'm going to copy the link as I've done. Then I'm going back to the environment, and I'll use a new command. This you might not find the cheat sheet, but you can Google online to see how do I change the directory using an Anaconda prompt. There are a lot of resources online. So I'm going to say change directly, which is CD. CD means change directory. I'll say CD. I'm going to paste Control C. I'll hit enter. So we see that we have moved from this environment to the environment. We are still in the same environment. We have moved from the location, the C drive location, to the exact working directory in that same environment, right? So that is what we've done. Virtually, whatever we do now, we are going to land ourselves in the working directory. So now I want to open Jupyter Lab, and I want it to take me exactly to the folder I call script. So I'm just going to say Jupyter Lab, and I hit enter. So you give it time, it's going to load. Then successful. Load. Boom. So it takes me to the directory which I was working. And when I go back here, I will show you. So remember, in this directory we have the data folder and the data types. This is the earlier preparation I had for this recording, and which is the script we are going to be using, the Jupyter Notebook. This is the folder I want to put the data we're going to be using in this training. So I'm going to go back so we see it. So in this, it has taken us to the directory, exactly to the directory. But you look at the other one, it takes us to the C drive, right? So from here we can go to desktop, we can find the folders, and we can open. So either way, you are still on the right path. And remember, through the Anaconda navigator, we are right, because we have already activated the right environment, and that right environment is my Joken in this case. So you can close it if you want, but I love working from this directory. Okay. In this case now, we are going to start looking at the topic we have today. So now we have prepared our coding environment, and now let's look at the topic we have today. In today's topic, I am going to be talking about Python data types that we have. Down a little bit. I'm going to be talking about the Python data types that we have. Hold on. All right. Okay. In this lesson, we'll be looking at the data types, the data format, and data structures, right? Specific. The other topics we're going to look at. And I'm trying to come up with the complete set of topics we're going to be covering, but I want to look at the basic. We're going to do a Python basics and Python data analysis. For the Python basic, we're looking at the Python data types, the format and structures. We're going to look at the Python statement, the Python loops, and Python functions. We will also consider other Python basic topics, right? As I put others there. So we'll think about other topics that will help your Python. So you need to know the basic. And I keep saying this, that using Python, Python itself is a tool. It's not domain language. So we apply the Python to other areas. And I'm going to show you, for example, what I mean by Python is a tool, and knowing Python does not mean you've known your field. So knowing Python is knowing a tool you can use to get the job done. For the Python data analysis, which is more like the advanced, you're going to be looking at data management using pandas, data fusion and manipulation, data wrangling, data visualization using matplotlib, data scraping, possibly, modeling with data, machine learning, and others. So we're going to do those predictive modeling and logistic analysis there. And those are special topics. And again, I said others because I am of opinion that we might evolve in this course, and when we evolve, we are likely going to add more topics. So we'll see how long we can go and what we can learn. And just before I continue, I just want to make it clear again that this lesson is free. I'm charging nothing for this course other than your attention, and I'm hoping by this I can be able to make impact and help you understand the intricacies of Python. We'll cover as much as possible. Python is wide, and I keep telling everyone, you get good at Python when you use it for your projects, right? When you use it to solve a task. So you don't learn it and keep it. Python keep evolving as every other language. So we have to also evolve. We have to grow. That being said, I'm going to introduce myself before I go into the lesson proper. For those who don't know me, my name is Kenneth Ekpetori. I had my bachelor's in geography and environmental management from the University of Abuja. I graduated as one of the best students. Actually, I graduated as the overall best student in the university and had the Vice Chancellor's Award. In my research, I focused on theoretical GIS and assessment of squatter settlement encroachment in GRAs. In my master's, I had my master's degree in 2021, focusing on maximum possible precipitation and programming. I'm currently a doctorate candidate, currently my final year, where I use programming like Python, JavaScript, and the rest of them, Java, R, and ECPy, for extreme weather event and PMP modeling. I also look at remote sensing application towards flood mapping. I do hydrological modeling of flood events and design storms. I develop web application for data access, do this for state agencies and federal agencies. Again, I have several research interests. So teaching Python is one of the things I do for fun, and I hope we can learn a lot. Now you get to know me. Now let's get down to business. Python data types. We have different types of data or different way Python think of data, right? So the idea is we want to start thinking like Python does, right? For humans, we like counting from 1, right? If you give us some set of numbers or say name of our businesses, we should arrange them. We want to arrange them starting from 1, right? If you give me 10 numbers, I want to start from 1, 2, 3, 4 up to 10. But Python thinks differently. Python thinks in zeros and ones and make up more numbers from there. So we think of starting from 0 instead of 1. So Python will start from 0. So we have these different data types, right? We have the numeric data, we have the Boolean data type, we have the sequence, we have the sets, we have the dictionary. Under the numeric, we have the integers, we have the float, we have complex. On that sequence, we have string, we have list, and then we have tuple. I'm going to dive in deep into what made them special and what is their characteristics and attributes. And then we can look at some example codes. We can write around them and we can see what we can derive from there. Again, just to let you know that it's possible that we can know the Python data type we are dealing with, right? There are 2 commands we use to check the data types. The first one is called the type command. You see here we have the type. So this type we're going to return the data type variable. So if I give it some I construct a kind of data. I don't know what it is, if it is an integer or a float or a boolean. And I'm going to ask Python, so okay, tell me the type by using the command type with the object. It's going to tell me, oh, it is an integer. We're going to see that. We can also check the data type by using the isInstance command that check whether an object belongs to a particular class. So we are going to see that, right? But just to summarize, the Python data types, like we say, we have numbers, right? Numbers can be integers, can be floats, can be complex. I will show you those examples. We have the Boolean, which could be true or false. So Python can use the command, okay, this is true or this is false, right? We're going to see how we can construct that, right? We also have the sets, right? I will tell you more about the set. We have the dictionary. I'll tell you about the keys and the pairs and what we use them. We have the sequence, which include the string, the list, and the tuple, right? And with that being said, let's take them one by one and see how we can make sense of these data types. Oh, before we go into that, let's also look at the description of this data, right? It's important I show you this. Integers basically store integer values. For example, we can say n is 20. I'm going to show you more about that, right? It doesn't have any decimal, right? Just whole numbers, right? Store the integer values the way it is. And then we have the float. The float store decimal values, right? Like 1.5, 2.5, or 2.2. There's always a decimal at the end, right? So we also have the complex that store complex numbers, which are real and imaginary parts. So we use this for electrical and more engineering, modeling, or construction. We're going to see that. We're not going to use it in this class, but I just want to mention to you that we have a complex Python data type. We have string, right? The string are used to store text or string data. So we have a test, like name of person, they are the known numbers. We use string, right? So you see how the strings are to store, like a quotation, right? We have that quotation to do that. We have the Boolean. The Boolean help us to store Boolean values, like we flag true, right? For example, we can see go through the range of data and see anywhere where wherever sales is lower than certain amount. Let's say, we did a sales or the business did a sales and they want to find where they had least amount of sales, flag that as to be true. They can give you a particular range. We're going to see when we do data management and manipulation, we're going to see how we can probably use Boolean to do that, to manipulate our data. To store a sequence of mutable data, we use lists. So lists are data that we can change. We can change them whichever way we want. I'll show you. I'm going to discuss all this in detail. We have tuple to store sequence immutable data. We have dictionary, right, to store key value pair. We have a set to store on indexed values. We have other data types which I'm not going to cover today, but it's good we mention them, like the frozen set to store immutable version of the set. We have the range to generate a sequence of number. We have bytes to store byte values. So we're not going to cover those three, but we're going to do justice to the rest of them. All right, let's look at the first one here, which is the string. So what's a string, right? A string is a sequence of characters enclosed within a single quote or a double quote. So we can use single quotes. We can also use double quotes. So sequence of character, right? Think of it like using a text, like names of people or whatever. We use strings to kind of enclose them. So characters could be anything like letters. It could also be numbers or special symbols, right? So we can use numbers, we can use letters. Those can make up the characters in a string. String data type is represented using str. So we want to create a string, we use this format. String data type work with text or character data. So we're going to see that what we mean by text, right? We can do many operations on string data. So we can search a string data, we can subtract, we can split them, we can do data fusion on them, right? So strings are immutable, it cannot be changed once we define them. So to do that, we can create a copy of the string data in order to be able to modify this data. So I'm going to show you an example so we can walk through that. So when I create this, I have my data types, I can be able to open the first notebook. So this is a good example. We're going to start with the first one. So this is a string. So we can see this is a name now, the business name. It's called ShopRite, and you have to take note of each of the character, right, in the business name from S all the way to E, ShopRite. So we can remember I told you from the beginning we can use the type function. So when we use the type is an inbuilt kind of function that returns the class of the data type. How does it classify the data type? So we use print. We say print the type of the business name. Remember, in this case, the object now is the business name. So we have assigned the string to the business name. So in this case, it's going to tell us if this business name is it a float, is it a string, is it a tuple. It's going to tell us by the time we say print type business name. So this is because we have assigned it to the object business name. We can also display the string by saying print business name, and it's going to display everything it contains in that string. We can access the second character of a string by indexing it. So we use the bracket, and in this case we're using the close bracket format to index it. So let me run this code block, and then we can see what we have. In the first instance, I'm going to try to explain this. In the first instance, we have defined the business name, and we assign the string ShopRite. The data type, we tell it get out data type, and it tells us that data type is a string, str is a string. And if we use the print, we are going to return the ShopRite. So remember, in this case, if you say print business name, it's not going to return business name. It's going to return what is inside that business name, which is now the object, and what's inside that business name is ShopRite. That's why it printed ShopRite. So in this case, we also say access the second character of the string. So we use the indexing bracket. This is the indexing bracket. It's different from the normal bracket. We use the indexing bracket to index the first. Remember I told you that Python think of numbers, a list of numbers or whatever, in starting from 0. The way Python count numbers start from 0. So when I say give me the first number, so in this case the first number is going to be 0, the second number is going to be 1, right? So let's see. So what it's going to do is that it's going to go through that command goes through the strings. So we have the shoprite. So S is going to be the 0, H is going to be the 1, 0 is going to be the 2, all the way to E. So think of it as 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I say give me the 1, we are going to see in this case it's going to index and just return just the second one, which is H. Because Python because in Python the first count is not 1, the first count is 0. So if I say return the first count is going to give me S, and S here is the first in the strings there. So if I say swarm, let me see E. So also in Python, when we say negative, we say -1, it means return the last number, right? So you think of it this way, to say the first is 0, the last is -1, and that's how Python thinks. because we can have a million strings, characters in a string that are concatenated together. So what Python want to do is Python want to be able to we use those easier way to find it. So we have the 0 is the first one, a -1 is the last one, and then we can also check for the fifth. So what will be the fifth? The fifth character in the shop right is going to be 4, right? Because we know already that we are counting from 0. So I'm going to run it. We have R here, which is the fifth character. So think of it that way as -1. All right. What can we do also with a string? We can also try to change the character of a string, but is it possible? Is it possible that we can go into a string and change the character? Are they mutable? Can we change the character? We can index them, we can pick them apart where we've shown, but can we change them? Can we go into here and change the S to T? Right? So because we tell it that now let's try to change, let's do this. So we say go to the object and look at the character inside and change the first one. This is what we're saying using the change bracket, which is 0, change the S here to T, and let's see. So let's run this and see what we're going to find. Python is going to complain. It's a string object does not support item assign. So we cannot assign a new one. We cannot assign T here. And that is it. So it means that strings are immutable. We cannot change the characters in a string. And that is what it means. That is the goal. This is the goal of this block of code, to show that we cannot change the characters in the string element. Okay, let's go to the next data type. The next data type is the integer. Integer data type is used to represent whole integer values, right? Like I showed you, they don't have decimal in them, right? They're just like whole numbers, right? They store, like for example, the shop number of a business, right? We cannot say the business in is number well, but you know we often want to associate business numbers or street numbers using whole number values, right? Integer data type is represented using the int. So what that means, we can create new values using int. One can store positive and negative integer numbers of any length, right? It can be 3 character, it can be negative, it can be very long, so we can store as many as possible. We can create an integer value using 2 ways, right? We can assign an integer value to a variable directly. We'll see that. We can also use the int class. So this is another function we can use called the int class to create integer values. We can also store integer values other than base 10, binary base 2, or octal base 8. So those are for those who are into spatial mathematics. You can be able to do that. Let's look at this good example. So in this case, we have the store integer value. The shop number here is 15, right? So this is an integer. Doesn't have a decimal number. It's a whole number value. All right. So in this case, we'll say the shop number is 15. We want to display the shop number, right? So we tell it to display shop number. So this is just to show you that we can print several objects at the same time using Python. So here we have assigned 15 to the as a value to the object shop number, and then we are printing So we see now that here this now become like a string. So that is one of the benefits of using a string. We can use it to define an output. So the shop number here in this condition, in this case, we contain the value 15, and we can also find the type of data by saying print type, the type of data. It will tell us if it is integer or if it is a float. We're going to find that, and let's do that real quick and see what we have here. If I run this script, it's going to tell me, okay, so the shop number is 15, right? Because in this shop none, we have already assigned the value 15 to it, and it tells us that the type is an integer. Let me change that to 15.5. Let's see what it's going to tell us. You see it changed, so no, it's a float now. So we use the type function to check to know we are back to integer to know. All right. We can also store integer using the int class, right? So for example, we have ID and we just have number. We'll say the ID is 45 and we'll say print ID, and what's the class of the ID? So let's see. Print ID 15, the 45. Let's see if we have a float number and we want to change it to integer. Let me see. So what happens is that because we are using the int command, we want to convert this float 45.1 with decimal number into integer. We're going to drop the decimal portion and just pick only the 45. So it means we can use the int function to convert other value type like a float number to an integer number, and then we can use it for our work. So that's what this chunk of code block is trying to explain. And then we also have the integer type. All right, we have other things. So for example, we can look at the decimal integer with base 8, decimal integer with base 16. All is within telling us the different integers and all that. I'll let you play with this when you have access to this notebook. Let's go to the next data type, which is float. Awesome. So we use the float data type to represent floating point values or decimal values, right? So with float, and then we can represent it using the float command. We can create a float variable using two ways. We can assign a float value to a variable directly, or we can use a float class, right? Just the way we use int to convert any values type to integer, we also do the same. We can use float to convert a value from integer to float and vice versa. Let's see. This is a good example. This is a wage for someone. This person earned 15,587 naira, rupees, dollar. I don't have a unit for it. You can give it in the unit of who you want. But I want you to pay attention to the float here. So the float portion, or the portion that made this wages to have become a float, is half the decimal, right? So we're going to find, first we want to be able to assign this value to the wages object. We'll print the object is going to contain the wages. Our values assigned, we can find the class type. We're going to do that real quick. I'm going to try to run this now to see. So it tells me, oh, the type is a float and the wages is this because the wages has been assigned. And we also have the string to define the wages. The next thing we can do is we can also try as much as possible to assign floats to a number. So we have a real number given to us, 65.2525, and we want to convert it to float. We just use the float command, like I said, and this is going to return the values and it will tell us the float type. So let's run this and see. So you see the type is float, and the value assigned to num is 65.25. So, and one thing we also have what we call essential floats. So sometimes numbers could, so in this case this is basically saying times 10 raised to the power 6. That's how Python represents it. So we have 4.55 times 10 raised to the power 6, but Python is going to say 4.55 e raised to the power 6, or e6. So in this case, we know this means 5.55 times 10 raised to the power 6, and if you have done standard forms in mathematics, we can expand this in standard form approach, right? By multiplying 4.55 by 1 million, or 10 raised to the power 6, right? So when we do a print, Python is going to return, in this case, this will be 455, or 4 million, right? Yeah, this will be 4,550,000. And then it will tell us the class type. The class type is a float. And from here, we can then convert from the float to integer and different data type, just to let us know that this is what we do. And then we also have another data type we can look at. It's called the complex data type. So we are not going to use the data type, but I just want to bring it up so we'll be able to understand that there are other ways Python represent data. So the complex data type is a number with a real and imaginary component, right? Can be represented as a plus bj, b times j, where a and b contain integers or floating point values. You can be used mainly in scientific applications and electrical engineering, so we're not going to use that today. We will not use the complex data type, like I said, in this training. So if I do a quick demo for you, you're going to see what I'm talking about. For example, we have 9 plus 8j. We don't know j can be anything, right? Think of when we write our simultaneous equations, quadratic equations, right? So the Python knows that one is a real number and the other is an imaginary number, which Python might end up finding. So we can ask Python to, we know x is 9 plus 8j, y is 10 plus 4.5j, z is 11.2 plus 1.2j. When we print it, Python is going to return the way it is, and it's also going to tell us the data type. So for each of them, it tells us that the data type is a complex one. And we have 9 plus 8j. So Python won't do any math because Python don't even know what j is. So in this case, j can be a value, right? Let us see if we can do manipulation. If we say j is equal to, let's say, 10, we still don't know yet, right? So complex data type can be defined based on the need, right? We also need to look at the structures and the formats and the desired need. So because here j in this situation have a different identification or different use here, because this data type is a complex one. So we may not be able to do that operation here, but I'm going to show you how we can be able to manipulate these in the next couple of talks there. So let's see. So we also have the list data type, list. So I like using lists because lists are mutable. We can change the numbers, the values inside. So the Python list is an ordered collection, also known as sequence of elements, right? Lists can be accessed. You can iterate the list. Iteration means to maybe loop through the list. We can remove a number from the list according to the order they inserted at the creation time. It can be used to represent the group of the element as a single entity, like business names. Lists can contain data of all data types. It can contain integers, can contain float, string. Duplicate elements are allowed in the list. We can modify the value of list element, which is mutability. And that is why I like using list, because I can change it in the midst of my code. I can do those changes. We can create a list by enclosing element in the square brackets. So we can use this square bracket. I also call it the indexing bracket to create a list. We can also create list by using the argument list. So we use the list and we're going to create that. And that's going to be part of your assignment. So you're going to be creating a list element and you're going to be using this list function to create it in the Python. So let's look at code example and see. This is a good example. So we have this list. So I call it my list. So this list contains, this is a string, Toyota, another string, Honda, and then we have integer, and then we have float because of decimal. Right, so we can display this list. Say print my list. It's going to tell us, and we'll also find the data type. So we'll also say print the data type, and let's see what's going to happen when we do that. So because here we assign the list to an object called my list, and then we can print that object. We have the values out. The same list will be printed. The value type, data type is going to tell us the list. So the type, the Python knows that the type is a list in this case. We can also access the element of the list, right? So we can access the element of the list. So for example, here we can say my list index, get me the first in the list. So in this case, do not expect Python to go in and just pick a T for you here, because in this case, the entire, look at the comma here. So this Python read this string as one number. Python also read this as one number. This is one number because of the comma. Everything inside is one number. So we can also have like a tuple inside the list. So Python is going to read everything as one. So in this case, if I say Python to go into this my list and get me the first element in the list, the first element in the list is going to be Toyota. So if I run that, we're going to have Toyota. But before then, we can also slice the list element, right? So look at this, for example. I tell the Python, use a square bracket, go in, give me, someone who doesn't know Python will say, oh, give me the numbers from 1 to 5. But that is not how it should be, right? So Python, this one here means give me the number from what? From the second. But if I put 0, 0 means from the first one. So give me the number from the second to the what? Fifth minus 1. Because there's always going to be a minus 1. Minus 1. So we have, Python is going to read, this is 0, 1, 2, 3. Right? Python is going to read, not going to read the first one. It's going to read from the second one, which is 1. We have 0, this is 1, 2, 3. They are no numbers, so it's going to stop where it sees number. But if we have more numbers, it's going to stop. I'm going to show you that, for example. Let me run this so we can see. So it's going to hear the first one index is Toyota, and list from the second one to the fourth. So we have 5 here. Remember, 5 minus 1 is 4. It's going to be the rest of the values. Let's try to play with this list more. So in this case, we can also tell it modify the second element of a list. So we can modify, that is the mutability. We can change the elements in the list. So we tell it that go into the list and change the first one. The second one, because we have my list which is 0. The 0 is the first one, so 1 is the second element. And change it to forward. Remember that the first we have Toyota, which is 0, 1, 2, 3. So we'll say you changed 1 to forward, and that's why we use the 1 here, the indexing bracket, to index it. So change it to Ford, and Python is going to change it to Ford. So we can also tell it to create a list using the list class. So we'll say my list. So we'll say my list, and then we use the bracket because this bracket comes with my list command, and we can pass in the list in there. Then Python is going to create it for us. So this is how we can create a list. Let's look at the next data type. Tuple. I think of tuple as they are ordered collections of elements that cannot be changed. They are immutable. So somehow I think of tuple as being like think of the computer. We have the read-only memory, we have the random access memory. So the read-only memory, you can only read it. You can only read, you cannot change it. That's how the tuple are. So since we cannot change tuple, what can we do? If you want to store the row numbers of a business unit that you don't want to change, you use tuple. And that's true. So as a data analyst, someone who's in data science, you must understand how do you represent your data? How do you store your data? So either you want it to be changed by others or you want it to be immutable. That's a question that you have to answer. So if you don't want the values, right, to change as you store data, remember to use the tuple. Tuples maintain the same order of insertion and allow us to store duplicate elements. So we can duplicate, for example, the row number or the shop number, the business number, the street number, and with the same number without having issue. So duplicate elements are allowed in the list. We can have multiple numbers of the same. We can create a tuple by enclosing elements in the parentheses. So we use a parenthesis, or we can also create a tuple by using the tuple class. So we have the tuple class. Just the way we have the list, we have the int, we also have the tuple. We can create that. Let's see example of a Python block of code that does that for us. So in this case, you see how we use parentheses for the tuple. We close the bracket. We'll have this range of numbers: 11, 24, 56, 88, and 78. So this has been assigned to the variable my tuple. We can print it. We can also find its class. Let's see. If I run this now, we're going to have, so the class is tuple, right? Give us the value. Let's see if we can access the third one. Can we access the third odd numbers in the list, right? Because you're going to use second. So we look at the 0, 1, 2, 0, 1, 2. So that's the third number. So when I run this now, I'm going to see it's 56. Can we slice it? Can we tell it to go from the third number to the fourth number? Remember I told you it's always going to be -1. So we have the 1, 2, 3, 56. 0, 1, 2, 3, 4. So we're going to have from 56 to 58 because the fourth number here is 5 minus 1. And that's why we can represent it here. We can also create a tuple using the tuple class. For example, say my tuple2, we have tuple, then we can have range of numbers. And because we already assigned my tuple, we're going to have this value. So let's run this chunk of code and see what we can find. You can also run this, uncomment it. So if you realize, I always comment and uncomment, right? I just say a control backslash or forward slash rather. Control forward slash control forward slash. It's going to keep commenting and uncommenting. So when I uncomment, like you can see the row here is uncomment. What it does is that line is not going to run. So when I run this code, I'm going to get the result here that I need to get. Can we modify a tuple? That is a very important. We know that tuples are immutable. We cannot change it. We cannot alter it. But let's see if it's possible that we can do something. We can modify. So in this case, I have an element called my tuple, and I tell the Python command. I said, go to the the element in my tuple and change the second element, which is 1. Well, 0, 1. Change the 24 with 35 and print it. Let's see. And let's see what the Python is going to complain. Tuple object does not support item assignment because they are immutable. We cannot change it. That is why it's very good if you want to store values, you don't want to change, you're doing business analysis of your company, you want to be able to know what values or what fields or what numbers or what data you don't want to change. Let's go to the next one, which is called the dictionary data type, presented by the dict. So dictionaries are unordered collections of unique values stored in key value pairs. So we use keys for them, key versus value, keys and value. I will show you what the keys and values are. We use a dictionary data type to store data as a key value pair. So dictionary type is represented using a dict class, right? Duplicate keys are not allowed, but the value can be duplicated. So I will show you what the keys are. If we try to insert a value with a duplicate key, the old value will be replaced with the new value. Heterogeneous, that is, string, list, tuple element are allowed for both key and value. So we can use it for both key and value. Dictionary is mutable, right? Means you can, right, is mutable. An object can be a key in dictionary if it is hashable. We can create a dictionary by 1, enclosing a key value in a curly bracket. So we use curly brackets. The same curly bracket, we also use it in a set. Alright, so the same curly bracket, we use it for set. We also use it for dictionary. We can also create dictionary by using the dict class. So let's see our Python command. For example, here we are trying to create a dictionary. We assign my cars. So this is the key. 1, 2, 3. And the values are Toyota, Honda, Ford. So you see that we use string here. But I have a question. Can we also use an integer? Can an integer be used? Can we change this 4 to an integer? Then we're going to experiment, and that's what we are doing here today. We can display the dictionary. So let's do that real quick. Because if we do that, we're going to get the content of the dictionary. We're also going to get a class type with a dictionary. Let's see if we can change this to 5.5. Yeah, so in this case we can do that. So the key there is 3. 5.5 is the value. We can create a dictionary using a dict class, right? So this is another way we can create the dictionary to my class. 1, 3, 4, 5. We can inspect it by saying print the class, tell us the class. So we have it. We can also access the value using a key name. My cars. So we want to be able to print just the second one, right? Or rather the first one, because in dictionary we don't index from 0 in this case. So we have 1, 2, 3. Yeah, because in this case we can see that 1 here is the key. Let us see if we can try 2. Let's see what we're going to have. Honda. Let's try the next key. Let's try 4 and see. We have Benz. Let's try 0. Nothing, because it's not part of the assignment, right? So what we are calling the key name. So we are assessing the value using what we call the key name. And that is what I want to draw the attention to. That with dictionary, if we have millions of keys and value, we can use the key to access the value in them. We can change the value of a key. For example, in this case, I say go to the first key, change the value to Kia Sorento, and print the first assigned one and print it there. So what this is going to do is that this command is going to go into this dictionary and change the key 1 value, which is Toyota, to Kia Sorento, and we can then inspect it. So we can have it as see we have changed Toyota to Kia Sorento, and that's how we can modify the content of a dictionary. So dictionary is very good, right, to store pairs. So when we write our functions or code, sometimes I want to use dictionary to store information which you can use. We have the key now. We know that every one contains Toyota, so we can always call it by the key. The next data type is the set. So I think of a set as a collection of well-defined objects, right? Set is an unordered collection of data items that are unique. They are unique, more like a collection of elements or objects that contains no duplicate element. Set data type are used to represent a group of unique elements as a single entity. If we want to store business store numbers, we can use the set data type. Set data type in Python is represented using the word set. Heterogeneous, they could be heterogeneous, that is, they could be string, they could contain list, they could contain tuple. Those elements are all allowed. But set itself is immutable, means we cannot index on set. Insertion order is not preserved, right? We can create a set by enclosing values in the curly bracket and also using the set class. So just like dictionary, we also use the set class, but in this case, we don't use keys and values in sets. Those are for dictionary. So let's see. So for example, in this case, you can see, for example, I define my set, right? I have integer, I have float, I have string. Because of the quotation, I can print it out and I will get the same value. I can tell it find a type. Let's see. Find a type. Say the class is a set. I can do more. I can create a set using a class. I say my set, so I tell it set, and then I define my put my parentheses, and I also use the curly bracket. I give it number 0, 100, 25.75 BMW Coca-Cola. And what I want to do here, then I can find it is a set. So that's how we can create a set. We can add element to the set by using just add. So you say my set to add 300 and then print it. Let's see. So we're going to see that initially we don't have 300, we only have 100, 25.75. Now we can have 300 to it, and this is going to give us the values we are looking for. We can also remove a number, so we have the remove function. So say my set remove 100, so to go into the set and find it and remove 100, and by the time we print it, we see there's no 100 again in the set, and that's how the set works. Alright, we also have the ninth data type, which I call the Boolean data type, bool. So the Boolean data type is used to represent true or false values. So this is very important when we want to, especially when we want to do logistic predictions, right? We want to see business sales, we say profit or loss, right? Profit or loss. When the income or what the net gain or net loss, right? We want to say we made profit or loss, we use Boolean. Boolean data type is presented using the bool. Like I said, Boolean values are used to evaluate the value of the expression if they are true or false. So let's take an example. For example, in this case, I say x is 15 and y is 25. So I say z, which means x is greater than y. And Python is going to find out if it's true, because Python knows what x is. X is 15. It also knows what y is. I say p is equal to x less than y. Z is x greater than y, and p is x less than y, and Python will find if it is. So what Python is going to print is going to be, if you say print z, it's going to find out if z is true or false, because it's going to comparison now, or if p, right? We can print the type. It will tell us that, oh, false means that for z, x is not greater than y. That's what I mean. And for p, x is less than y, and the type is Boolean. So we can do that. Alright, now that I have exposed you to the different data types, right, we can do a lot of work with this. We can learn more. I'll just give you a few examples. I'm going to make the script available so you can play with the script and change it the way you want. I've also demoed some of this code for you. I'll provide this code for you in the Google Drive so you can play with the code and understand more and be able to ask questions. Now, you're going to do an assignment for me. I give an assignment based on all the data types, so I want you to play with it. And you're going to, when you want to submit assignment, you're going to use one chunk of code, one script. The way I name it like this, so you're going to name your own, put your name and say assignment 1. For example, if my name is Kenneth, I'll say Kenneth underscore assignment 1, so that when I'm assessing it, I will see what you've done. So what you're going to do for me is very simple. You're going to attempt this assignment. I have 8 questions, and each questions have their subparts. So each of them are the data types. For the integer, for example, I have a salary here, salary range. You're going to use to answer the question. Write a code block that extract and print the last digit of the integer salary. So what I want you to do is probably to copy this. So when you go to define your own code, right, you're free to look at my own example to see. So I want you to go and play with it. Remember that although I showed you comma, Python does not does not deal with those commas, so you have to remove them. You remove them. Right, so what I want to see is I want to be able to see if you can do something like salary. Let's see if you can be able to go there and do, let's say, do 2. Is it going to give you an error? Int object is not subscriptable, so we cannot immute it. Then you tell me why. So I want you to be able to understand why you can do certain functions or changes, why it works and why it doesn't work for other types, and then you can report it. So we cannot be able to subscript, you cannot be able to index it, and this is the reason why, right? If I change this into a string and I run it, you see what it does is going to find the second one here. Remember, we have the 0 1 2, so this is 2 here. If I change this to 1, it's going to pick. So why did it, when we are doing we have the string, we can subset it, but once this is not a string, we cannot subset it because it's a tuple. Why? So this is what I want you to be able to interact with, and some of them are going to work, some are not going to work. I'll say write a code block. So you go to, what you do for me is, if you, this first one, integer, you just come here, and for example, if I want to answer that question, I will just come here. For example, I'm going to say number 1. I hope this is how you can write. You can change from code to markdown. Markdown help you to write, so you can check more online on how you can do markdown, right? And then I put a double stack. I can say number 1 question is on integer. It's an integer. This is how I change it. If I put it to code, that's if I'm coding now. I change it to raw. Can be like raw, but I want it to be in a markdown, and then I can run it. So this question integer. Then this is the first one. The second one, which is under integer, I go back to under integer. So the first one say, you see, write it, reverse the digit of the salary. So what I want you to do in this case is to reverse it in a way. So you go to find online and see a way you can revise this salary. So when we do like this, you can do salary underscore reverse, and you can see this. I'll put it up here, and I want you to use a command. You go online and find how you can reverse this salary and what value is going to be. So you're going to use this to get a new value that will be here, right? These are very simple tasks for you to do. Check if you can change the value of an integer at a specific index in a list. So I give you this for example, and let's use a real list so we can so you go in here and see if you can change the values. Okay, so I want you to understand. Let's look at the second one, which is float. I want you to understand when I say use these numbers, I want to take them away from the floats. from the tuple bracket so it doesn't create confusion for you. Let me leave them the way they are. So I want to put in a bracket so it's easier for you to find, but I realize the bracket can be misunderstood to be tuple, which I don't want. So for the float, I say write a code block that extracts and prints the integer part of a float point number. So here, for example, we have the 234.5689. So your code should be able to print only 234. I don't want the float part. Write a code to round a floating point number to the nearest integer. I just want to see only the nearest integer. For example, this is 24.5, so the next integer is going to be what? 25, because this is up to 5. Check if you can change the value of a float at a specific index in a list. Can you change the value of a float? So you find any one you can change here and change it. Create a float variable and print its data type. So this is a very simple assignment. I have the rest of them here. So you go through this assignment and try to see how you can attempt them up to. We have the set, dictionary, the tuple, the list, the boolean, the string. So you play with them and see how and what you can find. Okay, that being said, that is the end of the first lesson on data type, Python data types, and the way Python think of data type. Next time we're going to look at the Python statement, the loops and the functions, and we can dive in more. Hopefully in the next 2 lessons more, we start playing with real data, data analysis, and if you have data you want to share with me, we can use to do lessons and demo. You can be able to share. If not, I'm going to find data and share with you guys to play with. And I hope this helped. If you have any question, feel free to let me know, and feel free to watch and share, and hopefully we can make progress. Thank you, and see you on the next one.